Welcome back, everyone, and in this video we're going to be taking a look at the cosine rule, where similar to the sine rule, depending on what we're given in the problem, we can figure out the length of a side or the value of an angle, depending on what we're looking for. Now, let's go ahead and let's jump right in. So remember that these rules, the sine and the cosine rule, we're using them for non-right angled triangles, which is exactly what we have here as an example. So I went ahead and called the angles A, B, and C with capitals, and then the corresponding side, which is always opposite, the lowercase of that. And so what this is going to tell us is that A squared is equal to B squared plus C squared minus 2B cosine A. And I know it sounds like a mouthful and it looks pretty long. Now what this is going to tell us is if we are looking for A, we're going to write it as A squared is equal to one of the opposite sides squared plus one of the other sides squared minus 2 times both of those multiplied together. So the side that we're not talking about times the cosine of A. So I know that looks quite confusing, but just think about this. We have one length squared, and that's going to be equal to one of the other lengths squared plus the other length squared. And whatever those two lengths were, we're just going to multiply them together right here, not squared, with a multiplicative of 2 in front. And then we're going to have cosine of A. So the angle here must match the side here. It must be opposite. And the same can be true in 2 other iterations to give us 3 total. We can say that B squared is going to be equal to, again, A squared plus C squared, the other sides, minus 2AC, again, the other sides, times the cosine of B. And then if we wanted to find out what C was, well, it would be C squared is equal to A squared plus B squared, the other sides, minus 2AB times cosine of C. Now, it's really important that these right here are going to match whatever is over here. Now, let's take a look at 2 different scenarios where we might use this. Now, in one of those scenarios, we're going to be looking for a side. So we're going to be looking for this side right here. In fact, let me go ahead and replace this with a question mark. Okay, so if I'm looking for this side, which is opposite of angle A, I'm going to take that squared, and then that's going to equal to this squared plus this squared minus, and you know what, I forgot something here, minus 2. So minus 2 times whatever this is, times whatever that is, times the cosine of whatever this is. And if we square root both sides, we'll get our answer for the length of A. The other circumstance we'll use this is when we want the angle. In this case, we're given all 3 sides. We just want to know what this angle is. So again, these 2 are the exact same formula. They're just rearranged for whatever you're solving for. In this case, we're solving for A squared. In this case, we're solving for cosine A. So we just kind of moved all of this over to here. So if we want the cosine of A, we're going to take B squared plus C squared, subtract the opposite of the angle squared, all over 2BC, which is going to be, again, not A. So it might seem a little confusing, but I promise once we work through a couple problems, it'll all make sense. All right, so let's say we have a triangle ABC, where AC is equal to 8.6 centimeters and AB is 6.3 centimeters, and angle A is 50 degrees. We want to find the length of BC, and we're given our handy-dandy formula right there. So it always helps to draw this out. Every time you should be drawing this out. Let me go ahead and draw this triangle right here. I'll call this A, I'll call this B, and I'll call this C. So now that AB is going to be 6.3. Now remember, in this diagram, we could also call this C. AC is going to be 8.6. And again, in this diagram, I could call this little b. Now, angle A is 50 degrees. So let me go ahead and put in a 50 here. Now, what is going to be the length of BC, which when you look at this is also the same thing as angle A. So right here, you might see this formula a lot. It doesn't necessarily mean that we have to solve for C. What it means is that we're looking for this value, which in our case is A. And if you remember that whatever you're doing here, remember this and this are the other values. This and this are the other values, and then you're taking the cosine of the angle. So perhaps that makes a little bit more sense. So if we do want to find this A right here, I would know that A squared is going to be equal to, again, my other side squared, 8.6 squared, plus my other side squared, 6.3 squared, minus 2 times what those sides are that I just took care of, 6.3 and 8.6, times the cosine of 50 degrees, just like that. And once you put that into your calculator, As long as you're inputting everything correctly, you will get a correct answer. And if it's not correct, remember, this is a squared. We have to take the square root of whatever this side is going to spit out, so that way we can have the correct answer. And once you are doing this, and we're going to 3 significant figures, you should get 6.63. In order to be really correct, I'll put centimeters and box my answers. So if you did not get 6.63, go through your answer again. Make sure that what you're putting into the calculator is correct, and make sure that you're also taking the square root of each side at the end. I hope that video helped shed a little bit of light into what the cosine rule looks like. In our next video, we'll take a look at even more example problems so that we can see what situations we use this for. I'll see you there. Take care.